you add or subtract two polynomials, and what type of expression is the result? You add or subtract two polynomials by combining like terms. Like terms, same variable, like x, and same exponent, whether it's 1, 2, 3, or whatnot. What type of expression is the result? Well, it's usually another polynomial. The result would be another polynomial. Identifying and analyzing monomials and polynomials. A polynomial is a polynomial function of degree n has a standard form p of x equals a sub n x to the nth power plus a sub n minus 1 times x to the n minus 1 power plus yada yada, a sub 2 x squared plus a sub 1 x plus a sub 0, where a sub n minus 1, and so on, a sub 2, a sub 1, and a sub 0 are real numbers, and a sub n is not equal to 0. The expression a sub n x to the nth power plus a sub n minus 1 times x to the n minus 1 power plus a sub 2 x squared plus a sub 1 x plus a sub 0 is called a polynomial. And each term of a polynomial is called a monomial. A monomial is the product, and here's a good definition for you. A monomial is the product. Here's a good definition for a monomial is the product of a number and one or more variables with whole number exponents. A polynomial is a monomial or a sum of monomials. So a polynomial is a monomial or a sum of monomials. The degree of a monomial is the sum of the exponents of the variables, and the degree of a polynomial is the degree of the monomial term with the greatest degree. The leading coefficient of a polynomial is the coefficient of the term with the greatest degree. All right, so let's take a look at this list. X to the third power, that's a monomial. X to the third power is a monomial. Y plus 3y squared minus 5y to the third, that's not a monomial, that's a polynomial. So we'll write that, let's see. And I'm going to write it in decreasing order. 5y to the third plus 3y squared plus y. This is not a monomial. And then you have a squared bc to the 12th. That is another monomial. A squared b times c to the 12th power. That is a monomial. And 76 is a monomial. Now, identify the degree of each monomial. So the degree of x to the third is just, well, it's 3. And 76, the degree of 76 is 0. Remember, the degree, what is the degree? The degree of a monomial is the sum of the exponents of the variable. 76 doesn't have a variable. Or maybe you could look at it like this. This could be called 76 x to the 0 power. So the degree would be 0. How about a squared bc to the 12th? What's the degree? Well, let's see, it's going to be 2 plus 1 plus 12. Well, where did you get the 1? That's b to the first power. 2 plus 3 plus 12. That gives you a total of 15. Now, let's see. Identify the terms of the polynomial y plus 3y squared minus 5y to the third plus 10. Well, the terms are the monomials, the y, the 3y squared, the negative 5y to the third, and the 10. So let's see, y, 3, let's see here, write this, 3y squared, negative 5y to the third, and 10. Those are the terms. And we'll put them back up in there. Y, 3y squared, and then negative 5y to the third, and 10. Those are the terms. So identify the coefficient of each term. Well, the coefficient of y is 1. The coefficient of 3y squared is 3. The coefficient of negative 5y to the third is negative 5. And the coefficient of 10 is just 10. Identify the degree of each term. Well, what's the degree? Well, y, that's degree is just 1. Y squared, that degree would be 2. Y to the third degree would be 3. And again, you might look at that as 10x to the 0, or 10y to the 0. Y to the 0. There's a little lag on it. So, and that degree is 0. Now it says write the polynomial in standard form. And standard form is usually the decreasing order of the exponents. So you got negative 5y to the third plus 3y squared plus y plus 10. What is the leading coefficient of the polynomial? Well, the leading coefficient of the polynomial is going to be negative 5, and that's negative 5. Negative 5. It'll look a little better. It's the coefficient of the variable with the largest exponent. How can you find the degree of a polynomial with multiple variables in each term? How can you find the degree of a polynomial with multiple variables in each term? Well, do like we did just on the other page. What we did was we found the degree of each individual monomial, and then the largest degree or the highest degree was the degree. That doesn't look too. I can do better now. Degree. The largest degree was the degree of the monomial, of the polynomial. Was the degree of the polynomial. All right. Explain one. Adding polynomials. To add polynomials, combine like terms. Remember I said earlier that was same variable with the same exponent. All right. And not sure what that means? Let's take a look. You can do A on your own. Stop the video and take a look. Follow through it. When you come back, we'll do B. B. 10x minus 8x cubed plus 6x to the fourth minus 2. You know, I'm looking at that. This right here, that's not in order, is it? So I think step one, put in decreasing order. And that's what they do here. 6x to the fourth minus 18x cubed plus 10x minus 2. Good. And then this one here was already in. And then step 2 would be to combine like terms. Now, I said like terms were the same variable with the same exponent. So look at here. We've got 6x to the fourth and negative 7x to the fourth. So that's going to be minus 7x to the fourth. You got negative 18 cubed and 2x cubed. So we got negative 18x cubed. And 10x and x, so we got 10x plus x. And then we got negative 2 plus 5, negative 2 plus 5. All right, when we combine these, what do we get? 6x to the fourth minus 7x to the fourth. Well, 6 minus 7 is just negative 1. So you got negative x to the fourth, or negative 1x to the fourth. 18x cubed plus 2x cubed. Negative 18 plus 2 gives you negative 16x cubed. 10x plus x, or 10 plus 1 is 11. 11x. And then negative 2 plus 5 is 3. Is the sum of two polynomials always a polynomial? Yes. Okay, always, yes. And let's see. See these terms here? Okay. All you're doing is you're combining like terms. Combining like terms. You're combining like terms. That's all you're doing is combining the like terms. So what's it going to do? It's still going to be a polynomial. It's still going to be a polynomial. All right, your turn. Number 3. What do we do first? One, right, in decreasing order. And then 2, combine like terms. So let's see, let's check. Is this in, no, that's not in decreasing order, is it? Because you've got, I'm going to redo it in black here. You've got negative 9x to the 7th, and then you've got plus 17x to the 4th, and then minus 2x cubed plus 8x squared plus 8x squared. 4, 3, 2. There is no x, but we have a plus 4. So first, write them in decreasing order. And then you have 11x to the 3rd minus 8x squared plus 12. All right. Now I'm gonna kind of cover this up over here. number 4 here. So we don't have, I don't write over the top of it, and you won't be able to see it. Step 1, write in decreasing order. 2, combine like terms. So what do we got? We've got a negative 9x squared, negative 9x squared. Do we have any other 9x squared? Nope. So we got negative 9x, and I said squared, I meant seventh. Negative 9x to the 7th. So we got that. Plus, and then what's the next? 17x to the 4th. Do we have a 7? Do we have an x to the 4th over here? Nope. So we got 17x to the 4th. And then, oh look, now we got negative 2x cubed and 11x. So we got plus and then negative 2 negative 2x cubed plus 11x cubed. And then let's take a look. You got 8x squared. Oh, minus 8x squared. So those are going to cancel each other out. 8x squared minus 8x squared. And then we have a 4 here and a 12 there. So let's 4 here and a 12 there. So plus, and then 4 plus 12. So what do we got here? What is our final answer now that we combine those? You got negative 9x to the 7th plus 17x to the 4th plus, and then negative 2 plus 11, that's going to give you 9x cubed. And then 8 minus 8, those are just going to cancel out. Plus, and then 4 plus 12, that gives you plus 16. All right, good, good. Now let's try number 4. Let's try number 4. I may need some extra room here, so I'm going to hide that so it's out of the way. Now check first. Step 1, make sure it's in decreasing order. So you've got 3x to the 11th plus x to the 6th, x to the 6th, and then minus 8x. And then we have 4x to the 4th minus x plus 17. Step 1. Step 2, combine like terms. So we got x to the 11th. We don't have an x to the 11th over there, so we got 3x to the 11th. We got that one. And the next one, x to the 6th. So we got x to the 6th. Got that in cover. We got a 4x to the 4th. And there's nothing to combine that to. And then we have, here's our first combine here. We got negative 8x minus x, so plus negative 8x minus x. And then our last one is just 17. So wasn't a whole lot to combine on there, was there? So we have 3x to the 11th. See, that was positive, good. Plus x to the 6th. And then plus 4x to the 4th. Minus, and you got negative 8 minus 1. That's negative 9x plus 17. All right, negative 3. All right, good, good. Subtracting polynomials. To subtract polynomials, combine like terms. So you can go ahead and read A, And then when you come back, we'll do B together. Glad you're back. So what are we going to do here? We're going to combine like terms. They're already in order from highest to lowest. So negative 5x squared, x to the fifth, minus 10x to the fifth. And I wrote the third there. $10x to the fifth. Okay. And then what do we got next here? We got 8x to the third, and there's no 8x to the third. There's no x to the third over here, so that's by itself. We have minus 4x squared and minus 2x squared. So minus 4x squared minus 2x squared. No x's, but we have a constant 19 and a minus 9. So negative 5x to the fifth minus 10x to the fifth is going to give us negative 15x to the fifth plus 8x cubed. Minus 4 minus 2 would give you minus 6x squared. Minus 6x squared. Plus 19 minus 9 gives you 10. Is the difference of two polynomials always polynomial? Yes. Why? Well, you're just combining like terms. You're just combining like terms. Combining like terms. All right, your turn. All right. Now, let's see here. First, let's check and make sure, is it in decreasing order? Yes. 7, 4, all right, 4, 2, good. So, what do we need to do first? First, I would distribute, well, first, decreasing order. Order. Second, I would distribute the negative. Write it over here, negative. Distribute the negative. So this is going to be 23x to the 7th minus 9x to the 4th plus 1. And then plus, and we're going to distribute this. Negative times the negative, that's going to be positive 9x to the 4th. And then that's going to be minus 6x squared. And that's going to be plus 31. Okay, so first, distribute. First, right, make sure it's in decreasing order. Second, distribute the negative. Third, combine like terms. Okay, so let's take a look. What do we got? We got 23x, no, none of those, so we just got 23x to the 7th by itself. All right, good. And then 9x to the 4th, you got minus 9x to the 4th, and then plus 9x to the 4th, so you got plus and negative 9x to the 4th plus 9x to the 4th. I don't have much of a tail there, does it? This orange kind of looks a lot like that red, doesn't it? Maybe I need to put a different color on there. Let's change that. We'll do that green. I like my UT orange, but it's not giving me the contrast I like here. So we'll rewrite that. Make sure we got negative 9x to the 4th plus 9x to the 4th. And then the next one we got is negative 6x squared. So we got plus, and that's negative 6x squared. And then our last are our constants, 1 and 31. So we got 1 plus 31. And so I'm going to cover up 7 here real quick so we don't write over the top of it and it looks real messy. So what do we got here? We have 23x to the 7th. These two are going to cancel out. Negative 9 plus 9 is 0. You got minus 6x squared. And then 1 plus 31 is 32. So you see, you subtracted a polynomial by a polynomial, and you ended up with a polynomial. And that'll happen every time. Well, not every time, I guess in some cases. So first, let's check. Step 1, decreasing order. Is this in decreasing order? No. So we got negative 8x to the 5th, and then plus 7x to the 3rd, and then plus 20x squared plus 13x. And then we'll put that right there. Minus, and this is negative 2x, negative 2x to the 5th plus 9x squared. All right, step 1, make sure it's in increasing order. We did. Step 2, distribute the negative. So let's distribute the negative. You got negative 8x to the 5th plus 7x to the 3rd plus 20x squared plus 13x. Now, negative times a negative, negative times negative, that's going to give us 2x to the 5th. Negative times positive, minus 9x squared. All right, and we do this because it makes it easier to not get them, double negatives. You get rid of that stuff. Let's take a look. What do we got? Negative 8x, and then, so we got some like terms there to combine. Negative 8x to the 5th plus 2x to the 5th. There's no x to the 3rd over here, so we got plus 7x to the 3rd. Excuse me. We do have some x squares. We got a 20x squared here and a minus 9x squared there. So what do we got here? 20x squared minus 9x squared. And then last but not least, we've got the 13x. And there's nothing over here, so we're not combining it with anything. All right. So negative 8 plus 2 that's negative 6x to the 5th plus 7x to the 3rd. And then 20 minus 9 is 11, so you got plus 11x squared. And then plus 13x. All right. Now, before we move on, let's do a little review. What's the degree of negative 6x to the 5th? Well, the degree is 5. That looks more like an S. 5. What's the degree of 7x to the 3rd? That's 3. What's the degree of 11x squared? That's 2. What's the degree of 13x? That's 1. What's the degree of this polynomial? What's the degree of that polynomial? It is 5. The degree is 5. What's the leading coefficient? What's the leading coefficient? What's the leading coefficient? Negative 6. All right, good. Modeling with polynomial addition and subtraction. Polynomial functions can be used to model real-world quantities. If two polynomial functions model quantities that are two parts of a whole, the functions can be added to find a function that models the quantity as a whole. If the polynomial function for the whole and a polynomial function for a part are given, Subtraction can be used to find the polynomial function that models the other part of the whole. A, go ahead and read A, and then when you get back, we'll do B together. Glad you're back. B, the data from the U.S. Census Bureau for 2000 to 2010 shows that the total number of overseas travelers visiting New York and Florida can be modeled by the function T of x equals 41.5 x cubed minus 689.1 x squared plus 4,323.3 x plus 2,796.6, where x is the number of years after 2000 and T of x is the total number of travelers in thousands. The number of overseas travelers visiting New York can be modeled by the function n of x equals negative 41.6 x cubed plus 560.9 x squared minus 1,632.7 x plus 6,837.4, where x is the number of years after 2000 and n of x is the number of travelers in thousands. Estimate the total number of overseas travelers to Florida in 2008. In the equation, f of x equals t of x. And how would we find f of x? If t of x is the total and n of total of New York and Florida, and n of x is just the total of New York, if we subtract n of x from t of x, we would get f of x. And f of x would be the number of travelers to Florida in thousands. So you'd have n of x, or excuse me, you would have, this is t of x minus n of x. And that would give you f of x. So f of x would equal t of x minus n of x. So let's try that. I got a feeling we're going to try that. So what is step 1? Make sure they're in decreasing order. What is step 2? Combine like terms. So you got 41.5 x cubed plus, and that was 41.6 x cubed, 41.6 x cubed plus, and it was negative 689 x squared minus 560.9 x squared plus 4,323.3 x plus 1,632.7 x plus 2,796.6 minus 6,800, and that's 837.4. If you combine, let's see, 41.5 plus 41.6, that's going to give me 83.1 x cubed minus 1,250 x squared plus 5,956 x minus 4,040. That's not looking good. 4,040.8. All right. The year 2008 is 8 years after 2000, so substitute 8 for x. And if you put this in the calculator, it's about 6,154,000. About 6,154,000 overseas travelers visited Florida in 2008. Now here's one for you to do on your own. Number 8. When you get back, we'll do it together. Glad you're back. According to the data from the U.S. Census Bureau from 1990 to 2009, the number of commercially owned automobiles in the United States can be modeled by the function a of x equals 1.4 x cubed minus 130.6 x squared plus 1,831.3x plus 128,141, where x is the number of years after 1990, and a of x is the number of automobiles in thousands. The number of privately owned automobiles in the United States can be modeled by A was all of them, and then P of x negative x cubed plus 24.9x squared minus 177.9x plus 1,709.5, where x is the number of years after 1990 and P of x is the number of automobiles in thousands. Estimate the total number of automobiles owned in 2005. So A is the commercial, P is the private. So let's see. I'm going to say that T of x will be A of x, the commercially owned ones, plus P of x, the privately owned ones, plus P of x. And now it says 1990 here, and they want to know the year 2005. So we'll take 2005, subtract 1990, subtract 1990, and that's going to give me like 15, right? So 15 years. What we need to do first, let's write. So we got to write the A of x, and that's going to be 1.4 x cubed minus 130.6 x squared plus 1831.3 x plus 128,141. That's your A of x. We're going to add to that the P of x. And the P of x is negative x cubed plus 24.9 x squared minus 177.9x plus 1709.5. All right, so step one. What is step one? Make sure they're in decreasing order, and both are. Good. Step two, since we're adding, we're just going to combine like terms. So let's see what we got here. Let's start here. We got 1.4 x cubed and negative x cubed. So we've got 1.4 x cubed minus x cubed. And then we've got plus, and that's negative 130.6 x squared. And over here we've got plus 24.9 x squared. And then our next term, I thought I got rid of orange. Let's go make that red. I guess now, all right, 131. So we got plus, and that's going to be 1831.3 x minus 177.9 x. And then we have our last terms. We have the constants. Plus, and then you got 128,141 plus 1709.5. All right, let's add all that up. Remember, this is going to equal t of x, the total. So the total in a particular year, t of x, would equal 1.4 minus 1 is 0.4 x to the third plus, and then negative 130.6 plus 24.9. I'm getting, that's going to be a, what is going on with this computer here? I'm getting some lag here. All right, so 0.4x cubed, and that was minus x. Minus x cubed. All right, so that's 0.4x cubed, and that's going to be minus 105. Let's see here. Let's get our calculator involved. Negative 130.6. Negative 130.6 and plus 24.9 plus, there's something going on in the background on my computer and it's messing me up, plus 24.9. Is that right? Plus 24.9 plus, so I get 105.7. 105.7 squared. And then 1831.3 minus, let's do that, 1831.3. 1831.3 minus 177.9. We get 1653.4. So plus 1653.4. And then we got to add those two right there. Plus 128, 141. 128, 141. 128, 141 plus, what was 128 plus 1709.5, 1709.5, 129, 850.5, 129, 850.5, 129, 850.5. All right, good. So that equation gives us the total number of cars in the U.S. in a particular year from 1990 on, or an estimate. We want to know about the year 2005. So we're going to put T of 15 in there. We calculated that earlier. So you're going to have 0.4 to the 15 to the third power minus 105.7, and it's going to be 15 squared plus, and that was supposed to have an x right there, plus 1,653.4 times 15 plus 129,850.5. So I'm not going to try to do that in my head, so we'll try. We'll put that in the calculator. You got 0.4 times 15 to the third power plus 105.7, 105.7, and that's going to be 15 squared plus the next term, 1653.4 times 15 plus, and then the last term was 129,850.5. Is that right? 129,850.5. And we'll press enter, and we get 179,000 equals 179,784. 784. So, let's see. Let's check, make sure I got all that right. Oh, no, I didn't. See, that was supposed to be minus. So we fix that. So 132,219 is the correct answer. 132,219. 132,219. All right. So in 2005, there were 132,219 commercial and private vehicles. Elaborate. How is the degree of a polynomial related to the degrees of the monomial that comprise the polynomial? Well, the degree of the polynomial is the degree of the degree of the polynomial is the degree, is the largest degree, is the degree of the monomial, is the degree of the monomial with the largest degree. I hope that makes sense. How is polynomial subtraction based on polynomial addition? Well, subtracting two polynomials is like adding the first polynomial to the opposite of the second polynomial. And in much simpler terms, let's see, subtracting two polynomials. So if you have 1 minus 3, is that not like 1 plus negative 3? Same thing. You get negative 2, you get negative 2. Either way. How would you find the model? How would you find the model for a whole if you have polynomial functions that are models for two distinct parts that make up the whole? How would you find the model for a whole if you have polynomial functions that are models for two distinct parts that make up the whole? Just add them together. Add the two parts together. Add the two parts together. Essential check-in. Essential question check-in. What is the result of adding or subtracting polynomials? Another polynomial. It's just another polynomial. All right. Good. I hope you enjoyed lesson 6.1 and see you in class tomorrow.